your body temperature goes from low to high and back down to low again. And it takes 24 hours for that to repeat. Not 18, not 6, 24, plus or minus a couple hours. You also have a rhythm in sleepiness and wakefulness that correlates with that. We tend to be sleepy as our temperature is falling, getting lower, and we tend to be more awake or waking when our temperature is increasing. We have a clock over the roof of our mouth, a group of neurons called the suprachiasmatic nucleus. That clock generates a 24-hour rhythm, and that clock is entrained, meaning it is matched to the external light-dark cycle, which is, no surprise, 24 hours. Spinning the Earth takes 24 hours. Talk about jet lag and what jet lag really represents and how to push back on jet lag, shift your clock faster, and escape some of the severe bad things that can happen with jet lag, including just feeling miserable when you're traveling for work or vacation. So what is the perfect day? What does that look like from a circadian sleep wakefulness standpoint? You basically want to get as much light, ideally sunlight, but as much light into your eyes during the period of each 24-hour cycle when you want to be awake, when you want to be alert. And you want to get as little light into your eyes at the times of that 24-hour cycle when you want to be asleep or drowsy and falling asleep. How much is enough? Well, you don't want to go so high with the light exposure that you damage your eyes. Please don't look at very bright lights, so painful that they're likely going to damage your eyes. A lot of photon energy, a high amount of lux, LUX, comes through even cloud cover. A good number to shoot for, as a rule of thumb, is to try and get exposure to at least 100,000 lux before 9 a.m. 10 a.m. maybe, but before 9 a.m., assuming you're waking up sometime between 5 and 8 a.m. Okay, so get 100,000 lux. Now, you do not, I want to repeat, you do not want to stare at a 200,000 lux or a 100,000 lux light. It's very, very bright. The mechanism of circadian clock setting, and this is very important, the mechanism of circadian clock setting involves these neurons in your eye that send electrical signals to this clock above the roof of your mouth, and that system sums, meaning it adds photons. It's a very slow system. So here we're talking about trying to get that at least 100,000 photons, but not all at once, but you got to get them before 9 a.m.-ish, maybe 10 a.m. So what do? You go outside. If you want to get nerdy about this, quantitative, you could download a free app like Light Meter and take a look around your house with Light Meter, and you'll notice that even bright overhead lights are only emitting about 4,000 or 5,000 lux. It's going to take a long while of looking at those lights with eyes open in order to set your circadian clock and tell your brain and body that it's morning. Going outside, even on a cloudy day, could be 7,000, 10,000 lux. It's really remarkable how bright it is, meaning how much photon energy is coming through. Then I've recommended, based on scientific literature, that you look at sunlight sometime around the time when the sun is setting. And the reason for that, of course, is because it adjusts down the sensitivity of your eyes. Because here's the diabolical thing. While we need a lot of photon energy early in the day to wake up our system and set our circadian clock and prepare us for a good night's sleep 14 to 16 hours later, it takes very little photon energy to reset and shift our clock after 8 p.m. And that's why you want to, as much as you safely can, avoid bright light and even not so bright light between the hours of 10 or 11 p.m. and 4 a.m. You don't have to travel to get jet lagged. Many of you are jet lagged. You're jet lagged because you're looking at your phone in the middle of the night. You're jet lagged because you're waking up at different times of day. You're jet lagged because your exercise is on a chaotic regime. Some days at this time, some days at that time. What I want to talk about is perhaps one of the most important things to know about your body and brain, which is called your temperature minimum. Okay? Most of you know your approximate weight. Some of you might even know your blood pressure. Some of you might even know your body mass index. Some of you might know other things about your biology that have fancy names. But everyone should know their temperature minimum. Your temperature minimum doesn't require a thermometer to measure. Your temperature minimum is the point in every 24-hour cycle when your temperature is lowest. Your temperature minimum tends to fall 90 minutes to 2 hours before your average waking time. So let's say you're not traveling and your typical wake-up time is 5:30 a.m. Your temperature minimum is very likely 3:30 a.m. or 4 a.m. The temperature minimum can be determined by taking the last 3 to 5 wake-up times. So let's say you wake up 7 a.m., 8 a.m., 3 a.m., right, happens. Take those, add them together, average them by adding them up and dividing by the number of days. That'll give you the average. Okay, so now you know how to get your temperature minimum. Your temperature minimum is your absolute reference point for shifting your circadian clock, whether or not it's for jet lag or shift work or some other purpose. Here's the deal. If you expose your eyes to bright light in the 4 hours, maybe 5 or 6, but in the 4 hours after your temperature minimum, your circadian clock will shift so that you will tend to get up earlier and go to sleep earlier in the subsequent days. Okay? It's what's called a phase advance, if you'd like to read up on this further. You advance your clock. Okay? However, if you view bright light in the 4 to 6 hours before your temperature minimum, you will tend to phase delay your clock. You will tend to wake up later and go to sleep later. Okay, I'm going to repeat this because there's so much confusion out there and people talk about circadian time and all this. Find your temperature minimum. I tend to wake up at about 6 a.m., sometimes 6:30, sometimes 7. It depends a lot on what I was doing the night before, as I'm guessing it does for you. But that means that my temperature minimum is probably somewhere right around 4:30 a.m., which means that if I wake up at 4:30 a.m. and I were to view bright light at 4:35 a.m., I'm going to advance my clock. I'm going to want to go to bed earlier the subsequent night and wake up earlier the subsequent morning. And as I shift my wake-up time, my temperature minimum shifts too, right? Because each time we shift our wake-up time, our temperature minimum shifts, assuming that wake-up time shifts more than, 30 minutes or an hour, okay? If I were to view bright light in the 4 to 6 hours before 4:30 a.m., guess what? The next night I'm going to want to stay up later, and I'm going to want to wake up later the subsequent morning. Your temperature minimum is a reference point, not a temperature reading. Again, if you want to measure your temperature minimum and figure out what it is, 98 point whatever or 96 point whatever, that's fine. You can do that, but that information won't help you. What you need to know is what time your body temperature is lowest and understand that in the 4 hours or so just after that time, viewing light will advance your clock to make you want to get up earlier. And the 4 hours before your temperature minimum, viewing light will make you want to stay up late.